Hi all, this is Dr. K.G. Shanti, Professor, R.M.K. College of Engineering and Technology. In this presentation, we are going to study about modes of propagation. And this comes under propagation of radio waves, Unit 5 of antenna and wave propagation. Propagation of radio waves. The wave propagation characteristics between the transmitter and receiver are controlled by the transmitting antenna, operating frequencies, and the media between them. So whenever the signal travels from the transmitting antenna to the receiving antenna, it undergoes various phenomenon. That is the second point that is told here. So it undergoes various different phenomenon which will be described in the next slide. Now, electromagnetic waves or radio waves are oscillations which propagate with the velocity of light in free space. Okay. Electromagnetic waves, they consist of electric and magnetic forces. These electric and magnetic fields are at right angles to each other, and they both are at right angles to the direction of propagation. Or in short, electromagnetic waves are transverse in nature. Right now, look into the diagram of radio wave propagation. See here, I have a half wave dipole. This is how the waves emanate from a half wave dipole antenna. This picture shows how waves are propagating on the surface of the earth. Signal propagation. Propagation in free space is always like a light. That is, the wave travels with the speed of light. And once again, the receiving power is proportional to 1 by d square. What is d means the distance between the sender and the receiver. And once again, when a signal travels from the transmitting antenna to the receiving antenna, it undergoes the various phenomena. One is fading, shadowing or blocking, reflection, refraction, scattering, and diffraction. So these are the various phenomena that a signal undergoes when traveling from the transmitter to the receiver. Now look at this diagram. This is nothing but you have an object blocking the rays. This is going to be called as shadowing, right? A reflection. The wave impinges on a surface and gets reflected back. So this phenomenon is reflection. And you have refraction. That is, if I have different media with different refractive indices, then what happens here is the signal undergoes bending effect, right? So that is shown here as refraction. Then scattering, right? Here, when the signal impinges on any object that is lesser than its wavelength, then the signal gets scattered. Now diffraction is whenever the signal comes across sharp edges, what happens here is the bending of signals take place. Wireless propagation mechanisms. Now in the previous slide I was saying what are the various mechanisms that the signal undergoes when traveling from the transmitter to the receiver. Here the receiver is a car in the example shown here. One is a free space propagation, or it is called as a line of sight, which means that the transmitter and the receiving antenna is visible from the transmitting antenna. If that's the case, then you call it as line of sight. Line of sight wave travels large distance without any obstacles. Now comes what is called as reflection. When a wave impinges on an object which is larger compared to the wavelength lambda, right? See here in the diagram, say if I have a surface whose wavelength is large when compared to the wavelength of the wave, right? In that case, what happens here is reflection takes place. The signal from the transmitter hits the surface and then it gets reflected back, right? An example is the surface of the earth, buildings, walls, etc. Now comes what is called as diffraction, right? Now radio path between the transmitter and receiver are obstructed by surface with sharp irregular edges. In that case, what happens is waves bend around the obstacle to propagate further into the shadowed region, which you call it as Fresnel zones. Right? See here, the signal from here gets diffracted by this sharp edge and it reaches the car. Right? Even though the line of sight does not exist from the transmitter to the car, but the signal from the transmitting antenna reaches the car. Next is what we call it is scattering. Right? Now what happens here is the wave hits the object smaller than lambda itself. See here, lamppost or street signs, all that have that is these objects are they are smaller than the lambda, right? So that phenomenon is going to be called as scattering. Now, this picture shows the examples for reflection. Now, when you see reflection, you have your incident ray, you have your reflected ray. Say this is an example of your signal getting reflected, right? And you have what is called as a refraction. Refraction is nothing but it gets it gets traveling from one medium to another. Say the example is nothing but your rainbow, right? The next example is scattering. You know why the sky is blue in color. That's because of the scattering phenomenon. And then you have what is called as diffraction. Diffraction, what happens here is if you have some clouds, the signal from the light source is getting diffracted. So this is nothing but your diffracted light. Right now, this diffracted rays are nothing but represented as incident waves in this example. And you have a float. Float is nothing but your look at this part. It resembles that of an aeroplane, right? And the float itself will have waves crossed by it, and you have what are called as your incident waves. So what happens here is diffraction occurs. Now let us see the various modes of operation. Right now a wave can be travel from the transmitting antenna to the receiving antenna as three different types of waves. What are the three different types of waves? It can either travel as a ground wave or a surface wave, and the frequency range is up to 2 megahertz. It can travel as a sky wave or ionospheric wave. Then the frequency range is between 2 to 30 megahertz. It can travel as a space wave. The other name for it is tropospheric wave. In that case, the frequency is about 30 megahertz. Now let us see what is meant by ground wave or surface wave. Right? The signal travels along or near the surface of the earth, and hence it is called as ground waves or surface waves. In the case of ground wave, that is transmission, or when the signal travels as a ground wave, the transmitting and the receiving antennas are close to the earth and are vertically polarized. This type of wave propagation is used at broadcast and low frequencies. And it is useful for communication at very low frequency and medium frequency. Space wave or tropospheric wave propagation, and this happens above 30 megahertz. These waves travel directly from the transmitting to the receiving antenna in the tropospheric region. These waves do not follow the earth and also do not move towards the sky. The portion of the atmosphere above the earth and within 16 km is called troposphere. This region is useful for transmission and receptions of signals above the frequency of 30 MHz. FM reception is normally by space wave propagation. Sky wave or ionospheric wave propagation. Now here the waves travel upwards into the sky from the transmitter. They get reflected at the ionosphere to the receiver, and hence the name ionospheric wave. They are also called as sky waves. Why? Because the signals travel deep into the sky. It is also called as ionospheric wave because signal reception is by reflection of waves from the ionosphere, as I told you earlier. Generally, ionosphere is an ionized region where ionization takes place because of the presence of sun rays, and it is approximately 60 kilometer to 450 kilometer above the Earth's surface. Long distance communication is possible by this mode of propagation, and it is useful for frequencies between 2 to 30 megahertz. Now let us look into this diagram, and then I'll move back to the previous two slides. Now kindly look into this diagram. There are four paths shown here. You have path A, you have path B, and two paths, path C, right? Now what is path A is? Path A is nothing but the ground wave or surface wave, where the waves travel very near to the surface of the earth, and hence the name ground wave or surface wave. Right now, the second wave propagation is going to be sky wave or ionospheric wave. Now see here, the signal is transmitted into the sky, it gets reflected by the ionosphere, and it reaches the receiver, right? So hence the name sky wave or ionospheric wave. Why ionospheric wave? Is it gets reflected by the ionospheric region. And the third one is going to be called as space wave propagation. Now look at the path between the transmitter and the receiver shown by path C. The signal can travel directly from the transmitter to the receiver, and this happens in the tropospheric region, which is up to 15 to 16 kilometer just above the Earth's surface. Since it happens here, it is otherwise called as tropospheric propagation, right? Now here it can either take this path, direct path from the transmitter to the receiver, or it can even take an indirect path this way around. That is, in that case, indirect or ground reflected wave. So this is nothing but path C represents the space wave propagation. This slide shows the comparison of different modes of propagation. You have ground waves, very low frequency and medium frequency, that is used for submarine communication, AM, FM, television broadcast. Space or line of sight waves, high frequency, very high frequency and ultra high frequency. It is mainly used for satellite communication and mobile communication. Sky waves, 2 megahertz to 30 megahertz, microwave link and radar communication. Now look at this picture. The same thing what I have told you earlier. This is one another diagram showing it. See here, this is the transmitter, this is the receiver. The waves that travel very near to the surface of the earth are called as ground waves. The waves that make use of the troposphere of earth, right? That is going to be called as space wave, where the transmitter will be able to see the receiver, right? So that is going to be space wave, and the signals from the transmitter, they get reflected by the ionosphere and then come back to the receiver. So they are going to be called as sky waves. Now, there are a number of factors that influence the propagation of radio waves when traveling from transmitter to the receiver, right? And all the factors are listed below. Earth characteristics in terms of conductivity, permittivity and permeability, frequency of operation, polarization of the transmitting antenna, height of the transmitting antenna, transmitter power, curvature of Earth, obstacles between transmitter and receiver, electrical characteristics of the atmosphere in the tropospheric region, moisture content in troposphere, characteristic of ionosphere, Earth's magnetic field, refractive index of troposphere and ionosphere, permittivity of troposphere and ionospheric regions, distance between the transmitter and the receiver, roughness of Earth, type of Earth, meaning that it can be a hilly region, it can be a forest or sea water or river water. Thank you all.